that?
Shut up.
I wasn't invited to that study session.
Writing's on the wall.
Just kidding.
Alright, are you ready?
Wait, is that a fact?
It's what a fact.
They said about studying.
I think so, that's what they said yesterday.
Yeah, that's what they said.
I'm the
To
only
study for
A day
history.
studying.
Yeah, right? Bullet in my head. Oh, it's
I'm
pretty
failing
nice.
it anyways.
Alright, so anyway, if you have a problem like this, nice and simple, you have two ways to look at it. One way is to look at it graphically. And to be like, okay, let me graph the function y equals 5x. And if you graph that, it's going to be a line, slope of 5x goes to the origin. And if I want to know what the limit is at 2, I'm here. So I have to find out what y value that is. So you can think about it graphically, but what are you really going to do? Plug in 2 and find out what y value you're at. So the answer is just 10. So with limits, a lot of the time you can just plug in that value and find out what the limit is. Skip to number 3 for a second. The limit as x approaches pi over 6 of the tangent. Well, if I think about what tangent looks like, and everybody remembers, I'm sure, where are its asymptotes?
There, this is.
Negative pi over 2 and pi over 2. It gets split over the y-axis, and it looks like this. So pi over 6 is like here, so like I'm sure there's no problem with it. I can just plug in pi over 6. So this is going to equal the tangent of pi over 6, which why would I ever leave it like that when I can actually figure out the numeric value? Tangent of pi over 6, that's here. The y is what at that spot? 1/2, and the x is 3 over 2, so when I rationalize
1 over 1.
1 over root 3, and just leave it, don't rationalize, right, sorry.
So
So that's the answer.
This is graphically.
So this is actually analytically. Analytically is more like algebraically, but I'm kind of looking at it both ways. I'm kind of saying like, all right, what does the graph look like? Well, to get that limit, I'm really just going to plug in pi over 6. So weird. How about number 2? 4. Because if the graph is y equals 4, that's just up here, like that. So what's the limit at 3? It's just right there. That's up right. So pretty easy, right? Yeah.
Until you make it hard.
Until we make it harder. So if you can just know that this graph is simple, then just plug it in. What about stuff like this? What if I have the tangent instead? Oops. Instead of pi over 6, what if I look at the limit as x approaches pi over 2? If you were just going about this problem and you thought, oh, I'm just going to plug in pi over 2, you, first of all, would get a 0 in the denominator, and you'd be like, crap. So you'd have to decide, like, is this does not exist, or is it actually infinity? So you can kind of choose. You can choose to say, well, if when you plug it in, I think I get 1 over 0. Well, therefore, it's undefined. That's not going to be good enough, because I'm going to want to know, is it infinity or negative infinity, or is it actually does not exist? You're going to have to take a look at the graph. And because I know the graph looks like this at pi over 2, and I know that from the left I'm going there, and from the right I'm going there, this does not exist.
Well,
so there are some functions that have an asymptote, and it does not exist, because the function's going to oppositely signed infinities. But
wait,
what about if I look at, hold on, the secant of x. Wait, let's look at the cosecant. Sorry. if you try to plug in 0, and you say like, all right, cosecant of 0 is going to be 1 over the sine of 0, and the sine of 0 is 0, it's like, oh crap, this is undefined. It might not be, does not exist. Because remember, cosecant and secant look different. They have like these parabolas, and those parabolas maybe, it's not going to work, is it? Crap. Because when I graph that, cosecant goes with sine, right? So if this is sine, asymptote, asymptote, loop, loop, what is it going to be?
DNA.
DNA. Okay, you're not going to foil me.
So you just kind of have to like graph it in
You
your
kind of
head.
have to just graph it in your head.
Okay.
Or on the paper. But what about this, smarty pants?
You should put like.
There
There
we
we go.
There we go.
Wow, I still, why is everybody saying there you go?
What does that do?
Okay, so if I graph the absolute value of cosecant, what does that look like?
Oh, everything's,
Remember, here's cosecant, the absolute value takes everything under and flips it up. So cosecant's going to have its asymptote here, but now it's going to go wonk, and it's going to do it again. So at 0, what are we going to the left and the right? Where are we headed?
Infinity.
Infinity. So that one's actually infinity. Yeah. This is where, like, if you really suck at graphing, this gets pretty hard.
yeah.
Let's look at more. So, like, let's see, some other tricky stuff. What about oh,
That's undefined.
so if you first plug in 2, what do you get? If you tried to plug in, and not only do you get undefined, this one's actually just ultra weird because you actually get 0 over 0. I think have we talked about this before? That's called the indeterminate form. Whenever you get 0 over 0, it usually means there's like something else going on. It usually means you can get an answer. It's just going to be annoying. So, like in the trig, a lot of times you're going to get 1 over 0 and the answer could still be found. It could still be infinity. You just have to go graph it. But if it's like more algebraic like that, like it's a rational function, meaning it's a fraction, if you plug in and you get 0 over 0, that means it's probably a whole. So what you can do, instead of graphing it, do what we kind of did when we graphed it. We factored it. We canceled out the common factor, and then what did we do to find out where the whole went?
Plug that into
Yeah, we just plug that into the factored version, and that's all I have to do. You actually don't have to go graph it. You can just know, all right, this thing looks like x plus 2, but there's a hole at x equals 2. So the hole, it looks like this. Okay, it looks like this and has a hole here. So this is what that graph looks like. I don't have to go graph it. I can just know that the common factor cancels out, and then I can plug in. That's where the hole is, and that's also then where the limit is, because from the left and the right, I'll be approaching that y value. So the answer is going to be 4.
When you go to plug things back in where there's a hole, do you plug it back into the original one or the factor?
Factored. If you plug into the original, you're going to get 0 over 0 again. Okay, so let me say this again because it's tricky. If you plug in from the start and you get 0 over 0, there's probably an answer, you just got to find it. So one way to do that is to try factoring and reducing, and then plug in. So if you get 0 over 0, try number 1, factoring and reducing. Factor, reduce, period, then plug in. there's some other stuff you can do. Aren't you so glad we're still here together? So I'll keep this separate. I'll come back. What if you got something like this? Because who isn't trying to find that limit? Come on.
We know that, Jaden.
She's still mad about the treasure thing. Just let it go.
Forever and always.
First day of school next year, I'll be like, "Is you guys okay?"
Yeah.
All right, so if you
What?
want to say it again, is what? No, it stops here. So when we plug in 0, what do you get on the bottom? 0. What do you get on the top? 0. Oh, snap. Indeterminate form. I better write that up here. It's called indeterminate.
Close enough.
Indeterminate form.
Can you?
That's how you spell it, isn't it?
Why is it written
It just looks like it was written by like a left-handed.
Is that what
Why
that's
is it
called?
Yeah.
What do you mean?
Like, why can't you just make that
You know,
a
you just want to be familiar with
Well,
it.
it
It comes
is.
up in casual
Then
conversation.
root 9 plus x minus 3.
Wow.
Or it could be plus or minus 3, I guess.
You never know. There's
Nah,
always tomorrow.
Just -3.
It's
You're
nice to
just
look
making
smart.
it look more complicated.
No, because it can be
All right,
negative
so
3.
if you plug in and you get 0 over 0 again,
Negative
and
3
obviously
squared
I
is
can't factor and reduce this, another option is multiply by a conjugate. It's like deflating. Now, usually you guys multiply by a conjugate to get rid of square roots in the denominator. That's when you've used it before. And if you did some of the Are You Ready for Calculus packet, you were multiplying by conjugates to get rid of the square roots, and it was like crazy. But this time we're using it for the same reason, but in the opposite way. So I have nothing in the bottom to get rid of, but if I multiply by root 9 plus x plus root 9, magic will happen. So it's just like a little technique that mathematicians figured out, and they were like, here's a way to solve this. I will pass it on to you. And you will be so happy. So what I'm doing is I'm going to take this whole fraction and multiply it by this whole fraction. And what I hope is going to happen is stuff's going to cancel, and it'll give me something simpler that I can plug 0 into and get an answer. Because again, like I said, when you plug 0 into this and got the 0 over 0, that should tell you, there's a bigger story. That the answer's actually not undefined. There's something bigger, you just have to find it. Factoring and reducing is an easy way to find it. This is not such an easy way, but yet, it still works. So if we're going to multiply this out, I'm foiling the top. So first term times first term gives me what? Just 9 plus x, because the roots times the roots makes just the regular thing that's underneath. And then the whole point of multiplying by a conjugate is so that the inners and the outers cancel. So I don't have to write that down. Because this times this is going to be a negative of those two. And this times this will be a positive of the same thing. So the minus this and the plus this will cancel. So I never have to worry about the inners and the outers. I just have to do the lasts. So negative root 9 times positive root 9 is just a minus 9. See where I got all that? Then on the bottom, you've got the whole thing again.
Aren't you right back where you started?
Yeah, how does that make it less complicated?
Because it's 0.
Wait, let's see.
That'll be 1 over.
Because on the top, the 9 minus the 9 cancel, and then the x over the x cancels. So I have the limit as x approaches 0 of 1 over that, which you think is going to give you a problem, but it's a plus now, not a minus. So now plug in. If you plug in 0, I just have square root of 9 plus the square root of 9. So 3 plus 3, 6 on the bottom, 1 on the top. That is the answer. Right? It's like a good book or a movie or a short. Yeah.
This is probably really stupid, but
No.
is the square root of 9, can it be negative 3? No.
No. That's only if you have like x squared equals.
Okay. You're so
We're gonna have to
annoying.
have an intervention.
No, it's okay.
No, I was laughing.
I'm just saying, we're just gonna have to sit down, hug it out. I'm just kidding. Anyway. I'm just kidding, sorry. That's when I have x squared equals 9. If you square root it then I'd have x equals a positive and negative 3 because, like, if this is your original problem, x could be positive 3 or negative 3 and make that work. But if you have it like that, it's just the positive one. Because it's not, you're not like solving for x and telling me this could be positive or negative and it would work. It's just like a straight up expression and it is what it is.
Yeah.
So you just take it as positive. So it's pretty crazy that like that function, when you look at 0, I think it looks like something like this. I think it's like this. Oops, and 1's like way up here. When I look at 0, I have a hole. It is still a hole actually. Because it's not defined at 0 because I do have 0 on the bottom. But I have like a hole at 1/6. And so the limit is actually cool on either side. Thrilling, right? Okay, there's one more, but we're going to stop for today. And the homework for tonight is from the calculus book. So actually, we're almost finished with our book. Don't turn it in yet, but I'm going to start giving you stuff from the calc book. If you were absent yesterday, what I said also was, in AB, you guys are going to do this all over again. In BC, we won't do it again. We're obviously not doing all these problems. The circled ones were from last year. I don't even know that I want to pick those, so. Okay, so we are going to do
Wrong word.
number 15. And 19. And we'll do 31. And on the other side, we'll do 51 and 53. You guys totally burnt out.
Yeah. I don't know why I just got serious. It's like
These will take you 5 minutes. It won't take long. Just try to take a gander.